morning, everyone, and welcome to another one of our Cosmic Conversations. My name is Josh. I'm tuning in from Morrison. Actually, I'm not tuning in from Morrison Planetarium. I'm representing Morrison Planetarium while tuning in from my house. But we are excited to be joined here today by Svetlana Shkoyar. And you're going to be telling us about some of the awesome stuff that's been happening on Mars in the past few days. Hi, Svetlana.
Hi, Josh. Thank you so much for having me. It's a pleasure.
I see some cool space art up behind you. Can you tell us about some of the things? I see maybe Saturn and Enceladus.
Saturn's rings, yes. The tiger stripes on Enceladus, and the rocky sandstone of Arizona that's from a hike we took a while ago that kind of looks like Mars. So
if you hadn't told me, I'd be fooled. That looks wonderful.
Thank you.
Well, thank you so much. You are tuning in from the East Coast, right?
Yep, I'm in Maryland.
And you do a lot of your work at one of the NASA facilities, the Goddard Center?
NASA Goddard Space Flight Center here in Greenbelt, Maryland. Mm-hmm.
Super cool. So if we put up our open space feed, this is actually running in open space right now. I'm flying us around live, but if this is a cool talk and you folks want to replicate it for your family and friends later, all you have to do is head to the openspaceproject.com. You can download it, and you can do basically the exact same thing with the current 0.16 build. Check it out and give it a shot. So Goddard looks like a pretty cool facility from above. What happens there?
When I started my job, funny enough, it was only 3 months before the pandemic. So I only actually spent 3 full months working at Goddard. But Goddard is it's one of NASA's science-heavy centers. We have, Kennedy Space Center, which does the launching and all the rocketry aspects. We have centers that, like, for example, Glenn and Langley and Marshall Space Flight Centers, which are more propulsion heavy and more aeronautical. Goddard, as well as the Jet Propulsion Lab in California, are the two science heavy centers, as well as Ames in California. So we are kind of the centers that focus on all the planetary missions and we employ a lot of the scientists, and we do a lot of the astrobiology as well.
We got a lot of friends at JPL and Ames, so that's good to hear them shout it out. So when we talk about what's been happening at Goddard for the past few days, I imagine there has been quite a bit of excitement about events on Mars. Can you tell us about your connection to Mars? What makes you so excited about it?
Oh, man. I mean, Mars is our closest neighbor. It is the planet that in the past was the most like Earth. So in its past, it had a thicker atmosphere, a warmer climate. And my interest is astrobiology, the study of life out there. And so if we're going to have our bets on life anywhere in the solar system, one of the highest bets I would say would be on Mars, not in the form of life alive today, but in the form of ancient life preserved in the rocks. Because on Earth, any cellular organism or any components that sort of die get preserved in the rock, and then their components get kind of jumbled up into carbonaceous blobs called macromolecular carbon. And that stuff is basically all over the place if you search for it correctly in the rock record on Earth. And so we hope that Mars, if it did develop life, could have a similar rock record, which is why I'm excited about looking for signs of fossil life on Mars.
So we've just had our Perseverance lander with the Ingenuity drone land on the surface, and it's going to be looking for life, but it sounds like the search for life on Mars does not start with Perseverance. Can you tell us about some of the earliest attempts?
That's correct. NASA's search for life actually started with the Viking missions. So back in 1975, we launched twin rovers to sites on Mars that were roughly 4,000 miles apart from each other. And the Viking landers, they were not rovers, they were landers. This was NASA's first attempt to land something on Mars. We had seen Mars from orbit, but we had not landed anything. And the Vikings really represented NASA's first life detection mission. So there's a beautiful shot, of the Viking.
This, I think, is a model that's in a museum, but it's a pretty accurate recreation of Viking. These things were big, too. There's photos of, like, Carl Sagan standing next to them, and it's about the same height. And Sagan wasn't a terribly short person.
Yeah, for sure. And the Vikings were tasked with both characterizing the environment, the surface environment on Mars, as well as the atmosphere, but also looking for signs of life alive. So Viking was looking for living, breathing, metabolizing microorganisms, basically in the soil. And the life detection experiments were basically reacting the soil with components that if the organisms were, eating them and giving off energy, we would be able to detect that reaction as a product of life. We didn't know that much about the chemistry in Mars soil at the time, so we were so sure that if something was alive, it was definitely going to react and definitely produce a signal. So
for the early detection methods, these were based on science that held up here on Earth and then launched into this unfamiliar environment. And if you look, we just hung out at the Viking 1 landing site. The Viking 2 landing site looks kind of similar, not life abundant to be sure. So you'd have to look for really faint chemical signatures. So what kind of process happened to figure out if there was life inside the soil?
So there were several different types of experiments. One of them involved basically feeding compounds with radioactive carbon in them into the soil, so that if the organisms were there and they metabolized that radioactive carbon, it would give off a different product, and it was labeled with that radioactive type of carbon, and it would be detectable. And the other one was another type of reaction that was supposed to happen where you were supposed to feed something to the microorganisms, and if they reacted it, you could detect it in the soil. However, we didn't exactly know what the components of the soil were. We thought we did, and from orbit, we were able to get a really good understanding of Mars. And in fact, the Viking really gave us a good understanding of the water history of Mars. We finally saw for the first time all the channels and rivers and beautiful, landforms formed by abundant flowing water. And we had hoped to identify those things. So we did get a lot of things right. But when we did those experiments, we actually got very, very ambiguous results in terms of whether there was life or not.
Ambiguous sounds like a challenging term to have in the middle of your results sentence.
Yeah. We some of the results were positive and others were negative on the two different rovers. And so scientists started to scratch their head, and they weren't actually sure, had we detected life or a process that looks like life.
So we've sent a couple follow-up missions, and I recall you mentioning when we were practicing that perchlorates was one of the suspicions about what could have messed up the experiment.
Right.
And later we had our Phoenix lander check out the polar regions and help confirm that hypothesis. So what is a perchlorate, and how would that mess up the experiment?
Right. A perchlorate is basically a chemical component of soil. On Earth, it can occur naturally, or it can be part of like industrial processes. On Earth, we actually have perchlorates in everything from explosive to fertilizers, and they're pretty toxic to human health.
Those things I like hanging out by.
Yeah. So, and there are pretty exotic chemicals on Earth because most of the time we have to manufacture them. On Mars, they were actually all over the place, and the Vikings potentially detected perchlorates and didn't even know it. And so perchlorates are basically these salt components that can destroy organics if they come in contact with carbon-based compounds, which is what we were looking for. They can actually destroy them and make them not detectable by the instruments. And so they can give up basically a false positive signal, or they can mimic signals of life themselves. So basically, there are several different ways that the perchlorates can block or mimic a signal of life, the signal that we were actually hoping for with the Viking experiments. We just didn't know that they were so abundant, and that's potentially one of the culprits that we had detected instead of life.
If I recall back to my Martian rover history, it was after Phoenix that NASA's kind of focus changed. Instead of trying to understand what life was there, they started looking for water. And I remember follow the water being sort of the mantra. Yeah.
And Viking played a very important role in that mantra, because with Viking, we kind of said, we need to go back and re-examine what we know about the surface of Mars. And one thing we knew that Viking did confirm was that water was everywhere in the past, and on Earth, of course, water is very important for life. And water-rich environments, places like river deltas and lake bottoms on Earth, actually preserve in the rock record these microscopic signs of life, biosignatures, in the form of chunks of that carbonaceous material that comes off of any living components and gets basically buried in the rock. So this is what we knew about the rock record on Earth. Viking did at least confirm that some of our assumptions about Mars were correct, and that water was a good strategy to follow. So the next couple of rovers we sent, after the Mars exploration rovers, and Curiosity, Phoenix, and then the Mir, and then the Curiosity rover, have all essentially been sent to landing places that were rich in both aqueous, water-rich environments, as well as environments that we consider to be habitable. So environments having not just the water, but sources of potential nutrients for the organisms that they could have lived off of.
Well, funny you should mention Curiosity. We're flying around Gale Crater. Can you tell us, like, I understand this is a huge challenge, but sort of the sizzle reel, what was the biggest thing that Curiosity taught us?
Curiosity got us more proof that carbonaceous materials were found on Mars. Curiosity found carbonaceous materials, which was a huge step forward beyond any of the missions before. We were following the water. We were learning about the water-rich environments, but Curiosity gave us a detection of carbon. That was huge with the SAM instrument, sample analysis at Mars, which was a wet chemistry laboratory. The catch is, just like with Viking, we cannot prove life with these detections, because these carbonaceous compounds can be produced by life. They can also be brought in by meteorites from space, because they're formed in the interstellar medium. They're formed in space, and they get delivered to the surfaces of planets as well. So astrobiology is a very interesting science, because because it could be life, we can't really accept it as life until we've disproven everything else. We have to disprove all the other potential explanations. And with Curiosity, the catch is we're a step closer to finding evidence of possible past life. But there's still a lot of work to do, and there's still a lot of explanations to explore before we can do that.
So you could say we're going to persevere.
Persevere.
So I'm going to take us over to the other side of Mars to get us to kind of the exciting new hotness on Mars. But before I get there, Mary, I think we have a photo of Curiosity. Can we show that to folks? Now, Curiosity looks a lot like Perseverance. You could say they're sort of built on the same chassis. What could we look for that would tell us one from the other for the discerning eye?
It's interesting, because they're actually, if you're just trying to look at the surface, judge the book by its cover, the two rovers will look very, very similar. They're built off of the same skeleton. Perseverance actually has a very different suite of instruments. Mm-hmm. Some instruments that are flying to space for the first time, certain laser instruments that I'm interested in working on that are actually going to space for the first time. If you think about the mission goals, the goals of Perseverance are quite different than those of Curiosity. This is a return mission. So Perseverance is actually looking to find samples that may contain signs of life, biosignatures, to cache them, to basically drill through the rock and collect little cores of tubes of about 38 of those types of rocks. And in the future, another mission will come and bring those samples back to Earth, where we will study them on Earth and do the high resolution studies that need to be done to determine whether there was life or not in those samples.
Well, I don't think we're going to see Perseverance in our images, but we can certainly give you some context for where it has landed, because we are zooming into Jezero Crater right now. So I love trying to differentiate the spacecraft I'm seeing. I think if someone wanted to try and tell, you can actually look at the wheels. If you bring back that image real fast, Mary, the wheels on Curiosity have some funny little dots on them that spell out JPL in Morse code. Someone had a lot of fun designing those. And I would want to double check, but I think the wheels on Perseverance look significantly different. So that's how I'm trying to remind myself of what the difference is. And like you said, under the hood, they are completely different, but on the surface, they look very similar.
Yeah.
Okay, so let's go check out Jezero. So why Jezero? What makes this site so very special?
Yeah, so I mentioned habitable environments, environments that indicate water was running through them. And I think we're zooming in on a feature right there, which kind of looks, is that the delta that we're zooming in on?
I believe so.
Yeah, you can see basically a channel at kind of the top of now it's sort of the middle of the screen, and then it flows out into this delta looking feature. So you can imagine that this was once a flowing lake. Jezero was thought to have formed by an impact, so something impacted the surface, created this crater, and then back at the time when there was flowing water on the surface, that crater filled in with water. So this was essentially an ancient lake that we're looking at. And not only was it an ancient lake, but it was a very busy place where you can see this channel with the water was flowing into the lake, standing there, creating a lake habitat, and then flowing out on the other side.
And this can actually see that outflow if I get us lined up just right on the opposite wall. We found it in rehearsal, so I'm going to do my best. There we go.
Yeah,
over on the right side.
Yeah, there's the beautiful outflow channel. And so that delta is actually an area that we really wanted to explore when we chose Gale Crater as the landing site. And it's an area that we landed near specifically so that we could drive towards it and explore the mineralogy and maybe collect some of those deltaic samples. Because, as I mentioned, on Earth where there's water, there's life. And this would indicate on Earth, this would be a fantastic place to preserve signs of life in the rock.
So we had a question come in from Roger Chu. How do we know there was water in the crater? What's the conclusive evidence?
Well, one of the pieces of evidence is these features that we can see. We can interpret these channels and these deltas. That's not the only piece of evidence we need to know it was water, as you may have guessed. Mineralogy also. So we've never landed anything in Gale Crater, right? Every location we land in has a very different story and history. We've seen Jezero Crater. We've seen Jezero Crater from orbit. And so we've been able to sort of reconstruct the history based on the mineralogy that we see. And this is at a very, like remote sensing scale. So this is like kilometer scales that we can kind of guess the mineralogy based on remote sensing instruments and reconstruct the environment that way mostly.
So by looking at the geoforms, I should say the areoforms, Mars forms, we can see similar shapes that we know come from rivers and flowing water on Earth, and even in some contexts on Mars. That gives us a really strong indicator that water flowed there.
Right.
Fantastic. So we actually have a brand new photo. I think this only came out this morning of Perseverance actually descending down. And this, you may have seen some of the super cool computer animations. I'm going to show you one of the super cool computer animations because I think they're fascinating. But this is not one of them. This is an actual shot of Perseverance being dropped by its amazing rocket backpack called the Sky Crane that deposited it safely on the surface yesterday. So it is so cool to see those three little straight lines are tethers connecting it. And the fourth one must be data as well as a tether. And then the second it was down safely on the ground, the Sky Crane detaches. I shouldn't tell you about it. We're going to see it in a couple minutes anyway. So this is a huge vehicle dropped on the surface of Mars. And you mentioned the sample return. This Perseverance is never going to leave Mars, though. So how are we going to get those samples back?
Right. Perseverance is the first of a 3-mission architecture, part of the Mars Sample Return Campaign, the MSR campaign. So Perseverance is the rover that's going to identify the best samples, drill them, and put them in the little hermetically sealed tubes, the very tightly sealed tubes. And those tubes will either sit on the rover body in the belly, or they'll be basically deposited along its traverse in regions that are considered to be, safe and redundant in case there's some sort of, emergency or something like that. And so there's going to be another vehicle, another rover that's going to come, and it's going to be called the Sample Fetch Rover. So it's going to fetch that cache of samples. And then there's going to be an architecture that's going to launch that cache up into orbit around Mars, the Mars Ascent Vehicle. And then that cache will be sitting in orbit around Mars until another vehicle comes and rendezvous with it and returns it back to Earth, at which point the samples will be heavily fought over by all the instrument teams, the most capable instrument teams on Earth. And facilities will have to be built, and contamination protocols will have to be really, really, secured in place. And then we're going to have samples to explore for probably decades after that.
That's absolutely fascinating, because I've heard we do have some Mars rocks on Earth currently, but they're not Mars rocks we chose. They're kind of Mars rocks the universe holistically gave us.
Yep. The universe chose to eject them off the surface and have them basically land on Earth. Those are meteorites. Yes, we definitely have many types of meteorites from all over Mars that were ejected into space and basically haphazardly landed on Earth because the universe chose that. You're right. They've given us a host of, knowledge about Mars. We've actually found things like perchlorates. So going back to the Viking story, we've been able to confirm some of the things that we actually did find on Mars that were at the time a mystery, but later, as we studied the meteorites, helped us better understand Mars as a system and Mars's chemistry and geology. But as you said, we didn't choose those samples. And that means we have absolutely no way of knowing where those samples came from off of the surface of Mars.
Right.
So in order to do good astrobiology, if you really want to look for evidence of life, for example, in a sample from Mars, you really have to know its context, its environment. You have to know where it came from, what was surrounding it, how that organic material, if it's there, how it got there. And we even had cases of potential signs of life found in a Martian meteorite. If anyone remembers the ALH 84001 meteorite back in the 90s, this was a case, it's a story we love to tell in astrobiology of a great story of how to be skeptical about looking for signs of life. But
Mary has a stuffed animal of that worm-like structure they found on her desk at work.
Me too. I have the same worm on my desk.
We had a question pop up from Corey, one of our regular viewers.
Mm-hmm.
Would you go to Mars if you had the opportunity?
I love the homage to Opportunity rover there. I honestly, I'm not as much of an adventurer. I love to have my feet here on Earth, and I would love to stay here on Earth with my family. I have a 2-year-old, so not for me, not my cup of tea. I'm very happy to study Mars from safe here on Earth.
So I know a lot of folks had their names sent to Mars on board both Curiosity and I believe Perseverance as well. But you mentioned something on our practice that was a really cool shout out to what's going on Earth today that was included with Perseverance.
Yeah. So back last June, as the rover was being finalized and assembled, due to the pandemic circumstances, it still ended up being assembled and it flew, and everything just happened amazingly well and successfully. And this was very, very difficult given obvious pandemic circumstances. And so to honor the healthcare workers that have helped us along in this pandemic, they actually ended up putting on this aluminum plaque on the body of the rover on Perseverance that symbolizes our thank you to the healthcare community. And it is basically a plaque of the planet Earth, and it sits on a staff with the, the serpent, that symbol of healthcare. So the Earth is sitting on that staff with the serpent, symbolizing kind of like Earth is being held up by the medical community. So that was a tribute to the dedication of all the healthcare workers and all the folks on the team that really made this mission succeed despite these difficult circumstances.
Makes Perseverance name all the more meaningful.
All the more meaningful.
Well, thank you so much. Is there anything else you'd like to share with the audience, or should we turn it over to our video?
Just that sample return is going to be a very, very exciting thing. I mean, in the Mars program, it's something we've been waiting for a long time. Those samples may come back at the earliest in 2031. So in our lifetime, for sure, if not in the next decade or so. And maybe some of you out there will be the astrobiologists who will study the first samples returned from Mars, and maybe you'll grow up to be the astrobiologists that discover life in them. Who knows? So it's a very exciting time in Mars exploration for sure, and it's something that we're all very looking forward to.
That is a heady draft, to be sure. So thank you so much, Svetlana, for joining us here. It's been really fun exploring Mars and learning about the history of our search for life with you. I wanted to give a shout out to the NASA media team that created this awesome video. We're going to use it as kind of our send-off. So please watch and enjoy if you haven't seen it already. It is spectacular to fly alongside Perseverance and get to go see the surface of Mars through its eyes. So with that, thank you all for joining us, and we'll see you next week.